Hi everyone, my name is Julia DeMarines and I'm friends with Miss Jennifer. And I'm so excited to be here talking to you about space today. We're going to talk a little bit about the size and scale of the solar system. And I have an activity for you that you can do at home. And I can't wait to see what you'll come up with. And we have a special treat. My cat decided to join us. This is Bella. She loves to join video calls. Hi, Bella. Can you say hi to everyone? Hi. Let's see, let's begin. I see that you all know so much about space already. I see that you know about the asteroid belt and the Kuiper belt in our solar system, which is fantastic. The 4 inner planets and 4 outer planets. You know that there are some dwarf planets. Let's see, what else do you know? We are in a solar system. Excellent. Rocket ships go to space. Yes, that's how we get to space. That's how we discover what some far, far away things look like, is by sending spacecraft to these planets. And we'll talk a little bit about that later. So the sun is really hot and made of gas. Yeah, it's really hot. Stars are really hot. The Big Bang is how our universe started. That's a very excellent point. Maybe a little outside of what I will be talking about today, but really cool that you know that. Yeah, space is silent, so you can't hear sounds in space. Isn't that so weird? You need something like air to transmit sound waves. Okay, our solar system is in a galaxy called the Milky Way. Excellent, we're gonna be talking about that a little bit later. Space has 1 million galaxies, not quite 1 million, a little bit more than that. So I'm gonna ask you to take another guess how many galaxies the universe has. Okay. So a couple of guesses on what the coldest and closest planet is. Someone said Mercury is the closest planet. Yes, that is true. And Neptune is the coldest planet. And Venus is actually the hottest planet. Even though Mercury is close to the sun, did you know that Venus is the hottest planet? Isn't that so weird? It's not even it's not that close to the sun compared to Mercury. But because it has a big, thick atmosphere, do you know what an atmosphere is? It's all like the air that we breathe surrounding our planet is called an atmosphere. Venus has a big atmosphere. And it's not made out of the same atmosphere that we have here. It's made of mostly carbon dioxide. We have a little bit of that in our atmosphere, but we can't breathe that air only. We need oxygen. I like to joke that my cat here, you see my cat? She's surrounded by fur. She does not like to be held, but she's very furry and pretty small inside. So I always like to joke that she has a big atmosphere. Right, kitty? Okay. And only Earth has living things right now. So as far as we can tell, this is something that I study. I look for life in the universe. How cool is that? Earth is the only place we found life. So we're still looking. There could be other places out there that have life, but we haven't found it yet. So hopefully I didn't talk too long about all of this stuff, but I see you have a lot of questions. So maybe I can address some of them in the next video. But first, I want to present you something about the size and scale of the solar system. Okay, give me just a second to set this up. And I'm going to share my screen. Okay, hopefully you should see that. So space is really, 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 really big, and it's hard to think about. Like when you think about infinity, like, my brain hurts. When you think about all of the stars in our galaxy, it's like, my brain hurts. When you think about all the galaxies in the universe, my brain hurts. So we're going to talk a little bit about some space topics. I want you to take a guess what these blobs are flying at the screen. So do you think they're stars? Anyone guess stars? How about asteroids? Did anyone guess galaxies? If you guess galaxies, give yourselves a pat on the back. These are galaxies. This is created from an image called the Hubble Deep Field. It is probably my favorite image ever. The Hubble is a spaced telescope that stared for a very, very long time at an empty part of space. And what it saw was all of these galaxies. Now, a galaxy is, we live in a galaxy called the Milky Way. So a galaxy is a collection of stars that are kind of held together by gravity. So they're kind of like little buddy groups. They all hang out together because they're like held together by this invisible force called gravity. We feel it because when we jump up, we come back down. When I throw this pen up, it comes back down. That's gravity. And each of those galaxies has a ton of stars, and I want you to take a guess how many stars. So I saw someone said, I think it was, maybe someone was guessing number of stars or number of galaxies, but guess how many stars are in each of these galaxies. So the number is about 400 billion. 400 billion. That's way more than a million. 400 billion on average. You can have small galaxies, you can have big galaxies, but about average is about 400 billion. Now, I want you to take a guess how many galaxies there are in the universe. We don't have an exact number, but we have a rough estimate based on data. Okay, did anyone guess more than a billion? How about a trillion? Well, if you guessed somewhere in between there, you're on the right track. It is, again, about the same number, about 400 billion galaxies in our universe. Each of those galaxies has about 400 billion stars. That makes my brain hurt. Now, to think if only one of those stars in one of those galaxies has life around it, don't you think that's kind of silly? I think that there are so many possibilities that there could be life out there that gets me excited every day to do my job in space, to do my space-related research. Okay, so we just learned how many galaxies there are in the universe, about 400 billion, and each of those galaxies has about 400 billion stars. Now, how do you even think about that? So we're going to bring it back down to something more familiar to start thinking about the size and scale of the universe. We're going to start by making a model. We're going to start with something we're all familiar with, the Earth and the Moon. So I think you can see my little talking head here. I hope you can. But we're going to try and think about the size and scale of things. So I'm going to give you 4 options. You're going to pick one marble to be the Earth and another to be the Moon. So this is just guessing what you know about the size and scale of something we interact with every day. We interact with the Earth every day. We see the Moon, maybe not every day, but most days we see it. So here's marble number 1. It's a big shooter marble. Marble number 2, a little bit smaller. 3, your standard marble size. And then 4, this itty bitty one. I don't know if you can see it. I might, you can see the sizes on the screen here. So I want you to pick one to be the Earth, one to be the Moon. And based on just a guess, and I'll give you let you in on a little secret. I give this quiz to people of all ages, from students, elementary school students, all the way up to doctors and astrophysicists and astronomers and astrobiologists and smart, very, very smart people. Most people get it wrong. And I'll tell you why in just a second. So I want to know your guesses. which one do you think represents the Earth and which one represents the moon? So we're shrinking them down to scale, and there's only one combination that works out. So if we're to shrink the Earth and the moon down, they have to be shrunk at the same in the same way. Which one is the Earth? Which one is the moon? Okay. So are you ready? Drum roll, please. Sorry, I just heard my cat. Okay. The Earth is number 2, and the moon is number 4. Can you see that? So did that surprise anybody? It surprised me when I learned, because I was like, wow, like the moon seems so much smaller than the Earth. And that surprised me because when you look out at the moon, it looks so big. And it just seems like it's a lot bigger than that. But I'll give you a little hint. You can fit 4 moon diameters across the diameter of the Earth. I think you've probably learned about diameter, but that just means the distance across a circle. So because these are spheres, you have to imagine what it's like if you cut halfway through it and what the diameter is like. Or you can think of it from like end to end like that. Okay, so you can fit, 1, 2, 3, 4 moons across the Earth. It's not exact, but it's just about. And the other combination, 1 and 3, or 1 and 3, wouldn't quite work. So this combination wouldn't quite work because you can only fit about 2 and a little bit across the moon, across the Earth. So there is your little hint. You can fit 4 moons across the diameter of the Earth. And I want you to remember that because I'm going to ask you in just a little bit to find some household objects. You're going to need a ruler or some way to measure to find 2 things, one that fits 4 times across the other. Try and find something that is circular or spherical. Bless you, kitty. You can use coins, oranges, golf balls, exercise balls if you want to get really creative. The sky is the limit. Yeah, I think I used an onion once. Okay. So the next thing I have is a video, and I will play this that shows the size difference of all of the things in our solar system. I'm going to stop it at a certain point, and if this doesn't come through, I'm going to ask your teacher to play it. Actually, I don't think I shared the screen for optimum. There we go. Okay. Okay, so while I have you here, just to so you can see it bigger, Earth and the moon. Okay. All right, I'm going to pause it for there. So we saw some things that you might not have heard of. Ceres is a dwarf planet in the asteroid belt. I think we saw Callisto. Some of these are moons of the gas giants. Mercury, we know Mercury, so I'm gonna. not sure how good my voice will come through while the video is playing, so I just want to pause it here. So this one, you're probably thinking, what is this? So this is Kepler 22b, and it is not in our solar system. It's what we call an exoplanet, a planet that orbits a different star other than our own. So this is not in our solar system. So astronomers are looking for these planets that go around other stars because we really want to know if there's life out there. So this is not a real image. This is just an artist's idea of what it might look like. And this represents what the size of this planet is. Why it's in this video is a little bit outdated, so there might be more exoplanets discovered that are closer in size to Earth, but this one is so far the closest one in size to Earth. It's really hard to detect Earth-size exoplanets because they're small and they're hard to detect. So that's why this one is here, is just to show you the size of it compared to Earth. Okay, this one is not our sun. This one is a nearby star called Proxima Centauri. It's a very small dwarf star. So just a little lesson here. Stars need to have enough mass to basically kind of ignite on the inside. It's not really burning, it's doing something called fusing. So you need to have something bigger than Jupiter to have enough pressure, if that makes sense, to start fusing atoms together so they start what we call nuclear fusion. You don't have to remember any of this, but just know that you can have stars that are not that much bigger than our biggest planets, but they are still pretty massive compared. So that's why Jupiter is not a star, but you can still have stars that are similar in size to Jupiter. So this is a very small star. It's one of the nearest stars to our sun. But I want you to just pay attention to the next part for how big our sun actually is. Let's see if I can. I might have to. Okay, I'm going to stop this here. These are some of the biggest stars we've ever discovered. So pretty crazy, right? It's so big. Okay, so now that we got a idea of the size of things in our solar system and even beyond, let's go back to the Earth and Moon. Okay, so we have these marbles, right? So I know you probably don't have them in your hand, but I want you to take a guess how far apart they are. So do you think I'm going to stop the share really fast. Do you think the Earth and Moon are pretty close? Or do you think they're really far away? So I want you to take a guess. And you can tell your teacher in terms of whatever scale you want. You can say like, oh, they're like an inch apart or a centimeter, or you can say like the size of a chihuahua or a whale or a bus, whatever you think. So take a moment to guess, if we were to shrink them down to this size, how far apart are they? Okay, do y'all have your guesses? Are you ready for the answer? It's about this far apart, about a meter apart, so just over 3 feet. Did that surprise anyone? Okay, so here's an image kind of better showing how far apart they are in space. So it took the Apollo astronauts 3 whole days to get to the moon in a very fast rocket. Isn't that crazy? 3 days. You can fit 30 Earths in between the Earth and the moon. So that's another trick. Remember we had that first trick, 4 moons to fit across the diameter of the Earth, and you can fit 30 Earth diameters in between the Earth and the moon. So that's another way to remember those distances. So I want you, for an assignment, to find objects in your house that one fits 4 times across the other in diameter, and that you can fit 30 diameters of your larger object, your Earth, in between the Earth and the moon. So I want you to make an Earth-Moon scale. Once I used a spatula to measure, I found spatula was like, there were 8 spatulas in between my Earth and my moon. But you can find things to measure in between. So as long as you have something that fits 4 times across the Earth, and your Earth can fit 30 times in between your Earth and your moon, you can also calculate it by measuring the diameter of the moon that you found and finding something that's 4 times across in diameter. You can also measure the diameter of your Earth and multiply it by 30 and measure how far apart your Earth and moon are. So I hope you get to do this assignment. I hope to see some of your answers, what you find and come up with, because it's a really nice way to think about the size and scale of the solar system. So I have one more quick video to show. Hopefully, again, this works, and it's about distance. For every second, power of 10. I live not miles. All right, we made it back. Whew, that was crazy. That makes me dizzy every time. Okay, so we just learned about the size and the scale of things. We just did this crazy zoom out video of our solar system and even beyond our galaxy. And we got to have a glimpse of what our universe kind of looks like. And we zoomed back in and now we're back here. So I can't wait to see your assignments and maybe I can get to answer some of your questions after the holiday break. Thank you so much for having me. Happy holidays.